Hello guys, welcome back to my video. My name is Margareth Stevany Sinurat. I'm college student from Mathematics Education Study Program 2019 at University of Medan. In this video, I will explain about chapter 8 is Euclid Element. Euclid Element. The first Euclid figure. In its development, UNI mathematics gave birth to many mathematicians who have contributed greatly to the world of mathematics to this day. One of them was Euclid, the great Greek geometry. Euclid is known as the father of geometry, the ancient mathematician who produced monumental works. The work is the Elements. The book became a famous human work and will always be used throughout the age. Now the Elements is contained in school textbook dealing with geometry and number theory. His position in history lies mainly in his great textbook on geometry called The Elements. The book consists of 13 book sections. The significance of the book, The Element, does not lie in the statements of personal formulas it makes. Euclid's contribution lies in the way the materials and problems are arranged and their overall formulation in planning the preparation of the book. Euclid was the first person in the world to establish a school of mathematics in Alexandria. In the field of geometry, Euclid gave an important legacy to the world, so it's not wrong if Euclid is called the father of geometry. The significance of the Elements does not lie in the statement of personal formulas it makes. Almost all the theories contained in the book have been written before and have also been proved to be true. Euclid's contribution lies in the way the materials and problems are arranged and their overall formulation in planning the preparation of the book. Here involved, most importantly, the selection of the arguments and calculations, for example, about the possibility of drawing a straight line between 2 points. After that, he carefully arranged the arguments so that they were easily understood by the people who follow him. Since the invention of the printing press, the book was immediately published in thousands of editions with various styles. The second, Euclid's books. Euclid wrote many books as a result of his work. One of Euclid's famous works is his book entitled Stoicia, or The Elements on Geometry, which became a textbook used in a secondary school around the world for more than 20 centuries. The book consists of 13 volumes as follows. The first volumes, the contents start from axiom, definition, and theorems of geometry. There are 48 geometrical theorems in this book. The first 26 propositions contain triangles, including the propositions of two congruent triangles. Theorem 27, 30 until 32 concern the parallels and the sum of the angle of a triangle. The proposition 33 until 48 concern parallelograms, right triangle, and square and their areas. Theorem 47 is about the Pythagorean's theorem, and Theorem 48 is about inverse of the theorem. The second book, volume 2, describe the relationship between rectangles and squares. Algebraic properties such as the distributive law P plus Q multiply L equal PL plus QL are explained geometrically. A rectangle whose length is P plus Q and breadth is L has an area of P plus Q. However, this rectangle consists of two rectangles. The first is length P and width L, so the area is PL, while the second is Q length and L width, so the area QL. So the area is equal to PL plus QL. The third book, volume 3. In this book, there are propositions regarding circles, chords, tangents, and measuring angles. Volume 3 discusses the properties of circle. For the ancient Greek, the circle was the most perfect flat shape. One of the properties of the circle discussed in volume 3 is that the tangent to the circle at a point P will be perpendicular to the radius of the circle OP. Therefore, volume 4, this book discusses geometric painting using Euclid's tools. With Euclid's tools, he draws triangle, pentagon, squares, hexagon, and regular 15ths by dividing the arcus of the circle, drawing regular end terms. A hexagon is created by first making a regular triangle and pentagon inside a circle with one of the vertices coincident P. Using a compass, the other vertex of the regular 15 can be obtained. Thus, until the 18th century, it was assumed that all polygons could be written with Euclid's tool. But in 1796, Carl Friedrich Gauss proved that a regular polygon whose sides are primes can be painted if the prime number is Fn equal n plus 1 for n equal 0, 1, 2, 3, 4 in a row. The mathematician responsible for volumes 3 and 4 was Hippocrates. The fifth, volume 5. This book contains the basis of Euclid's theory of comparison regarding recomparison made clear so that the future of the discovery of irrational numbers by the Pythagoreans school can be solved. The ratio of two similar quantities A and B, both line segment, area, and so on, is the same as the ratio of the same magnitude C and D. If there are positive integers m and n, which are integers so that for ma and b correspond to mc and d, or a divided b. Euclid's theory was later developed by Dedekins and Westerners. The sixth volume 6. This book examines the concept of the similarity of two plane figures, which was known by Pythagoras and his students. For example, two triangles are said to be similar if the ratio of length of the corresponding sides is the same. Two similar triangles of the same size are said to be congruent and congruent. Furthermore, the similarity of two polygons can be checked through the similarity of the triangles that form them. This book also contains the form of similarity which is presented perfectly and homogeneously. The seventh book, volume 8 until 9, this book discusses number theory which contains a simple factual basis of Pythagorean number theory, which is now called Euclid's algorithm, which can be known by cross division to determine the large good factor GZF and least aliens multiply KPK. In this case, also added evidence regarding the uniqueness of prime factorization into prime factors, calculation of power and roots, summation of finite geometry series, and proof of the theory of existence on infinite prime numbers. Furthermore, it has been explained in the Pythagorean theorem regarding odd and even numbers. In Book 9, found the postulates regarding the formation of perfect even numbers, such as 6 equal 1 plus 2 plus 3 equal the sum of the factor. If Sn equal to n minus 1 is a prime number, Sn is perfect number. The 8th volume 10, this book is based on previous studies of Theotius. The study started with a long research. It's very difficult to be able to see in its entirety because of its impractical form and the ultimate goal of the type of irrational numbers. The 9th volume 11. This book contains some data involving the principle of duality which applies to strict line and planes. Next is the most important theorem in trigonometry, and the last is the parallel surface theorem. Next, volume 12. This book is about calculating volume, followed by comparing a circle to the square of its diameter and a sphere to the cube of its diameter. Then the relationship between the tube and the perpendicular to the cone, all of which is proved in the Euclidean theory. But the most important thing is Euclid's success in determining the volume of the pyramid. Book 13. This book is based on a study by Eudoxus which explored the facts regarding the completion of general forms in special figures. What is important about Euclid's Elements is the paradigm it set for the way that mathematics should be studied and recorded. He began with some definition and terminology and ideas for geometry, and then he noted 5 important postulates or axioms of geometry. A version of this postulate is as follows. The first stroke is set of different points that cross the line. The second, for each pair of segments, there is a unique point E on the line defined by A and B, so that E is between A and B, and the segment AE with segment EB is congruent. The third, for its point C and its point A is different from C. There is a circle with center C and radius CA. The 4 right angles are congruent. These are the 4 standard axioms that provide our conception of Euclidean geometry. The 5th axiom, the topic of intensive study for 2000 years, is a parallel called postulate in previous formulation. The 5th, for every I line and every point P that does not lie on either are M unique lines stroke P such that M is parallel to L. Euclid's influence on mathematics. Euclid's format helps standardize Greek mathematics. The subject discussed by Euclid include forms the Pythagorean theorem, equation in algebra, circles, tangents, geometry and of space, theory of proportion, prime numbers, perfect numbers, positive integers, irrational numbers, three-dimensional images. Euclid left a useful legacy for the development of mathematics. Compilation of the result of the work of previous mathematicians through the book Elements show the common trait that the development of mathematics cannot be separated from the role of Greek thinkers. Criticism of Euclid actually triggers the emergence of non-Euclideans that complement Euclid's discussion. The shape of the parabola, hyperbola, and ellipse began to get the attention of mathematicians. The significance of the elements does not lie in the statement of personal formulas it makes. Almost all the theory contained in the book have been written before and have also been proved to be true. Euclid's contribution lies in the way the materials and problems are arranged and their overall formulation in planning the preparation of the book. It should be noted that the book, The Elements, is not only an extension of the stretched field of geometry, but also contains extensive section on algebraic problems and the theory of addition. It's fair to say that Euclid's books was an important factor for the growth of modern science. I think that's all from me that I can explain on the topic of Euclid Elements. Please forgive me if I had mistake in my explanation in this video. Hopefully this explanation video is useful for you. Don't forget to share this video with your friends on social media too. Thank you and good day.